Okay, hello again, everybody. This is the second lecture. I am Dr. Ghanbari, Assistant Professor of Islamic Computer Science, Islamic Azad University, Ashtian branch from Iran, right? Again, I would like to thank you to coming to this class. This class contains blockchain, which is very important and new technology and very popular, right? Maybe someone thinks blockchain and Bitcoin is same thing, but as you know, these two topics and two subjects are completely different. I will talk about these two things, okay? I explain blockchain, I explain Bitcoin. This course contains a complete reference of blockchain, which take about 35 hours, okay? We explain everything by details. In this introduction, I will explain something about this course, okay? This 35 hours course. Firstly, we talk about what the blockchain is, explaining why the blockchain, the philosophy of blockchain, and what is the difference between blockchain and Bitcoin. In fact, Bitcoin is a currency, okay? Just a currency. But the blockchain is a technology behind the Bitcoin, right? In fact, the structure of blockchain is based on peer-to-peer, which is distributed system. I explained the distributed system in the last presentation. In this course, we talk about something especially defined for the blockchain, okay? We explain some thing about the formal definition of blockchain. What the blockchain is. Essentially, blockchain can be defined as a like this, okay? Blockchain is a decentralized digital ledger that records transaction across multiple computers, okay? This definition is more formal, right? What the ledger is a list that will be recorded, everything inside this list, right? Before talking about blockchain, we have to clear what the block is, what the transaction is, okay? Look at please to this picture. In this picture, we have A, B, C, D, which are four nodes, okay? These nodes are trusted because everything is clear, okay? A want to transfer $50 to D. Everybody knows that A have now $150 and can transfer for example, $50 to D, okay? And this will be accepted by C, D, A, B, okay? And also after that, A want to transfer $30, okay? $30 to C. Everybody knows that A has now $100 and can transfer $30 to C, and just this will be accepted, okay? Red one is accepted. Again, C wants to transfer $40 to D. Everybody knows that the C has not enough money, okay? C has just $35, right? I cannot transfer, for example, $40 to D, okay? This will be failed, okay? And this will be this not be accepted, right? And also, finally, A wants to transfer $100 to B, which is not acceptable because everybody knows that A now has $70, okay, which is less than 100. And this transaction cannot be acceptable. Everything must be recorded in a ledger, okay? Everything is open, and everybody knows about this transaction. This transaction can be stored in a block, okay? In a block, we explain the block, what the block is. In this picture, in the left side, you see 3 blocks, okay? Block 15, block 16, and block 17, right? Each block has mainly 2 parts, okay? Each block contains and consists of 2 parts. The first part is something like a metadata. In the metadata will be stored in a metadata the hash function of each block and the current block will be stored. Also, the hash function of the previous block also will be stored, nouns, and the Merkle tree of this other information that will be stored in a head part. Okay, in fact, head part is not include some data. Just it is the some information and some metadata, right? And in a block body, a list of transactions will be stored in a one block. Regarding to the size of each block, each transaction, we can have 2,000 to 4,000 transactions in a block can be stored, right? And also maybe 1 megabyte to 8 megabyte can be the size can be considered, right? As you see, we have a block, a list of blocks. Each block can be connected to the other block by using a hash, okay? The hash is very important. We talk about hash. Hash is a function that converts any data to a fixed size, okay? We have different types of algorithm for hash function, okay? Hash is a mathematical function. This function can be used and very popular and we have a lot of function. During this course, we talk about the hash function and the circumstance of finding hash function, which is a one-way cryptography. Okay, we explain the hash, what the hash is, and what is the difference between hash function and hash and cryptography. In fact, cryptography is two-side encryption. Okay, just you can transfer, you can convert data to a plain text to a cipher text, and also you can also convert a cipher text to a plain text. This is an important thing. But in a hash function, you cannot do. You can just transfer and convert a plain text to the hash function. Okay, this is very important, and this function can be used for making connection between different blocks, right? We also talk about the definition. We define the blockchain. We explain what the hash technology is. Hash must be collision free. Okay, collision free means that we have the same hash function for different text, right? Different plain text. This is a for example here, okay, this one is this right side is a hash function, bi0 something else, okay, bi0. So these two types of hash are same, but the right side, the left side is not same, okay. This thing is hash collision, okay. An algorithm that used for hashing must be collision free, and the research show that MD5 algorithm has a lot of collision, and nobody can find the collision for a SHA-256, right? This is very important algorithm, and this is good and very stable algorithm for hashing technology. Okay. Just in a second part, this other part, we talk about the Merkle tree. Merkle tree. Merkle tree also is a tree that contains everything about the transaction. Okay, if you have, for example, here 1, 2, 3, 4, 5, 6, 7, 8 transaction A, B, C, D, E, F, G, H, or a list of transaction. The first two transaction, we can convert the transaction to a hash A for transaction A, hash B to transaction B. Hash A and hash B can be convert, and this combination, by combination of these two things, we can have a new hash. Okay, the hash will be stored in hash A, B, C, D, and also we have hash C, D, E, F, G, and H. Okay, completely. We also can have in a root, we have a new hash A, B, C, D to H. Okay, this one is Merkle tree, Merkle hash. Okay, this Merkle hash can be stored in a block. Okay, we explain everything in this during this course, right? Okay, the problem, there's other problem in a blockchain that we talk about it is consensus algorithm. Okay, consensus mechanism and consensus algorithm. Consensus mechanism is very important things. Okay, and in a blockchain technology, which is open system, and the consensus mechanism is completely different and complicated than the distributed system, traditional distributed system, right? In a distributed system, what the consensus is? Consensus is we want to have the same opinion about something. Okay, for example, we want to different nodes want to have an agreement about, for example, commit or canceling of a transaction. Okay, or leader election, or sometime for time synchronization. This is a problem in distributed system, and everybody can have an agreement. This agreement is consensus. Okay, we have different protocol for this kind of agreements. For example, Paxos algorithm and Raft are two different algorithms that is mainly used for these purposes, right? But in a blockchain, we have some problem that cannot use Paxos or Raft algorithm because we have an open system. Maybe the system have malicious nodes or malicious user. The malicious user may cheat the algorithm, and everything must be must be trust, right? For example, if someone cheat the algorithm do not know it's correct or not. Okay, we explain what the malicious algorithm is, what the malicious user is, and what is the effect of malicious user in a consensus problem. This is very important. We talk about Byzantine algorithm, Byzantine problem, general problem in blockchain technology and something else. Okay, during this course, we explain this thing and the importance of and the circumstance of this kind of algorithm. I will talk about by detail, right? And finally, what a smart contract. Okay, smart contract also is important, very, very important, because a smart contract is a contract between two or more different users. Okay, the users are not know each other. Okay, and they have to follow a rule. The rule can be written by a programming language. Okay, for example, Solidity programming language, which is very useful for Ethereum system. Okay, Ethereum blockchain, and this kind of Solidity, this kind of programming will be explained during this course. Okay, hope you have an enjoyable course in a blockchain. This class was finished.